All right, this is review sheet number 10. It's a little confusing because actually we got review sheet number 10 after we got review sheet number 11. So this is review sheet number 10. There are 10 questions on here. Some of them are a little tricky, and probably the trickiest question on this was number 1. Number 1 is so tricky that I'm not exactly sure the algebraic way to solve this. The only way I was able to solve this was by plugging in some numbers, okay? So let's look at it. Number 1 says, what are two whole numbers whose product is 147, and whose quotient is 3? Product, I know, means multiplication, and quotient, I know, means division, okay? So I'm looking for two numbers that when I multiply them together, it equals 147, and when I divide the two of them, I get 3. So since this is a little bit easier, I'm going to start with some numbers and try and figure out, okay? So I'm thinking a quotient of 3. Well, I know that if I have 33 and I divide that by 11, I'll get that to be 3. Okay, so there's two numbers whose quotient is 3. That works. Now, it needs to, when I multiply these two numbers together, I need to get 147. When I multiply 11 and 33, I don't get 147, I get 363. So there's 11 times 33. Those are not the two numbers, okay? So that doesn't work. All right, so now I need different numbers, okay? Let's say, well, 3 times 6 is 18, okay? So I would know that 18 divided by 6 is 3. So let's try 18 divided by 6. We know that's 3. So there's another one that works. The quotient is 3. Okay? Yep, that's true. Now, if I multiply those together, am I going to get 147? Well, let's see. 6 times 18, 108. Not enough. So we know that it's less than 11 because 11 was way too much. And we know that 6 actually comes out to be less than 147. So it's got to be a number in between 11 and 6. So let's try the next number up from 6. Let's try 7. Okay? So 7 times 3 equals 21. So one number would be 21. The other would be 7. One up from 6 would be 7. We know that equals 3. So that is two whole numbers that their quotient is 3. Okay? Now, if I multiply 7 times 21 together, what does it need to equal in order for this to be true? Well, it needs to equal 147. And it does. So our two numbers whose product is 147 and whose quotient is 3 is 7 and 21. Is our answer. That's probably the trickiest problem on the whole sheet. And I have a feeling that a couple of you got stuck on it and then just kind of decided not to even try the rest of the sheet because they thought, the first one's difficult, I'm not going to get any of the other ones. The other ones aren't that bad. Okay? Number 2 is a similar question, but they give us a little bit more information. Okay? What we did up here, this is called guessing and checking. I guessed and I checked it. Didn't work. I guessed, I checked it, it didn't work. I guess, I checked it, it did work. If you want to do guess and check on the state test and you want to get your full points, you must have 3 attempts. 1, 2, 3. So even if I was able to guess 7 and 21 on the second time, I would still need to show a third time in order to get full credit. Okay? So that's what we're going to need to do on number 2 here. It says the length of a rectangle is 3 times the width. The perimeter is 48 centimeters. What is the area? We need to answer that question. What is the area? Use the following table for guess and check. Remember that you must have 3 attempts. Okay? So we're going to at least break this up into 3 attempts. Okay? So we need to pick a width, all right? And so we're thinking here, we got a rectangle. We need to pick a width, and we know that whatever this is 3 times it. So let's pick 2. Okay, so we're going to start with our width of 2. So we know if our width is 2, our length would be 3 times 2, which is 6. Okay, if I have 2 here, 2 here, 6 here, 6 here, 6 plus 6 is 12. 2 plus 2 is 4. 4 plus, 6 and 6 is 12. 2 and 2 is 4. 12 plus 4, anyone? 16. Perimeter would be 16. And our area, 2 times 6, would be 12. Is that what we want? Perimeter 48, 16. We're too low. We need to guess a higher width, okay, a longer width. So let's try 5. 5 would be our x. Our length would be 3 times 5, 15. Okay, and our perimeter then would be 15 and 15. You can even use the calculator if this is getting confusing. 15 plus 15, and then our two widths, which are plus 5 plus 5. Our perimeter would be 40. And when we take 5 times 15 to figure out our area, we get 75. So now we look. All right. Let's see. Perimeter is 48. 40. Not there, but really, really close. Much closer than the first time when our perimeter was 16. So I'm going to try now a width of 6. Okay, if we do a width of 6, our length has to be 3 times our width. 3 times 6 is 18. To figure out our perimeter, we take 18 plus 18, because we have 2 lengths, plus 2 widths of 6 equals 48. Our perimeter is 48. Ooh, that matches. Let's figure out what our area is. 6 times 18, because area equals length times width. Our area is 108, 108. So, we have found our width, our length, and once we have found our width and our length, we can figure out our perimeter and our area. So what is the area if the perimeter is 48? Well, if the perimeter is 48, our area is 108 feet. Sorry, 108, I had to look at, I just assumed it was feet. But when I reread the problem, it says the perimeter is 48 centimeters. Not feet, centimeters. Area means that our label has to be not centimeters, but centimeters squared. There's problem number 2. A equals 108 centimeters squared. A little bit easier than the first one. Let's look at number 3. Evaluate the following. Woo, fractions. I know there's multiple parts to this problem, okay? First, according to my order of operations, PEMDAS, PEMP, parentheses, I got to deal with the parentheses first, okay? And in fact, I noticed that this is really what I need to do is I need to distribute first, okay? I need to do my distribution first. So, I need to take negative 2/3 and multiply it by 6. And I need to take my negative 2/3 and multiply it by negative 1/2. Remember, the negative sign goes with the number after it. Negative sign goes with the number after it. Okay, so I'm just going to bring down my 5/6. Okay, now I have negative 2/3 times 6. If you have a calculator, negative 2/3 times 6, negative 4. 5/6 minus 4. Okay. Now I need to do my second distribution, which is multiplying negative 2/3 times negative 1/2. Negative 2/3 times negative 1/2. And I get 1/3. A positive or a negative? This will be a positive. There's no sign there. So I'm going to be adding 1/3. And then I'm just going to bring down my plus 3/4. All right. So I've finished my distribution. My next step, when I add or subtract fractions, I always have to have a common, wait for it, denominator. You got it. Common denominator. A common denominator between 6, 3, and 4, because we can change this 4 to whatever denominator we need. Okay, so we need a common denominator between 6, 3, and 4. The least common multiple between 6, 3, and 4 would be 12. So now I have to think, okay, what did I do to 6 to get to 12? Well, I multiplied it by 2. 6 times 2 equals 12. I do the same thing to the top. 5 times 2 equals 10. Okay. Now I want to turn 4, negative 4, into a fraction with 12 on the bottom. Well, in order to do that, all I need to do is multiply 12 times 4. If I have my calculator, 12 times 4, 48. Did I move that too fast? That's 48. Because if we type this into a calculator, negative 48 over 12, okay, that's what this is, I should get negative 4. Let's see. Negative 4. They are equal. Okay. Next up, I have my addition sign. Okay. And I want to make 1/3 into a fraction out of 12. What did I do to the 3 to get to 12? I multiplied by 4. Whatever I do to the bottom, I must do to the top. 1 times 4, you guessed it, 4. Adding sign. I want to turn 3/4 into a fraction in which the denominator is 12. What did I do to 4 to get to 12? Well, I multiplied it by 3. Whatever I do to the bottom, I must do to the top. 3 times 3 is 9. So now I have my problem, and I have a common denominator on all of my fractions. Now, I will get an answer with a denominator of 12. Okay? So, if I take 10, and I can actually do all of this right in my calculator. Okay? See if I can get both of these on the screen at once. Okay? So, I'm going to take 10 minus 48 plus 4 plus 9. Hit the equal sign, I get negative 25, and there's my answer. Negative 25, the 12 stays the same, and there's a fine answer. It's a fraction, it's fine. But if we wanted to make that into a mixed number, okay, we could take on our calculator negative 25, divide that by 12. Actually, you have to do it as negative 25 ABC 12. Otherwise, it comes out as a fraction. Okay. And this reads as negative 2. So this equals negative 2 and 1/12. Of course, we don't need a calculator to do that. We could say, well, how many times does 12 go into 25? It's 2. How many times, so 2 times 12 is 24. 25 minus 24, that's 1 left over. We keep the same denominator, add our negative sign because this is technically negative 25. Negative 2 and 1/2, or 1/12, is also a correct answer. Either one of these answers would be correct. Number 4. A scale drawing for a construction project uses a scale of 1 inch equals 5 feet. The dimensions of the rectangular family room on the scale drawing are 3.5 inches by 8 inches. So on the blueprint, we got 3.5 inches by 8 inches. What will be the actual area? Those are our two most important words in that. Actual area of the floor of the family room after the construction project is completed. It does not want inches, it wants feet, the actual room. Okay? There's a couple different ways to do this. One of the most interesting, I thought, and kind of made the most sense to me, was a student showed me this. So here's what he did. He drew his rectangle, okay, and on the blueprint, it was 3.5 inches by 8 inches. He knew that area equals the length times the width. So he multiplied those two together. 3.5 times 8. And he got, so if we use our calculator, 3.5 times 8, he gets 28. So I have to think about that for a second. All I did was multiplied inches by inches. So I get the area equals 28 inches squared. Okay? 3.5 times 8. Let me double check that. 28. Okay? So, this is on the blueprint, this is the area, but we don't want the blueprint, we want the actual, and we know that for every 1 inch, it actually equals 5 feet in real life. So what he does then is he takes his 28 inches and he multiplies 28 by 5, and he ends up with 28 times 5 equals 140. 28 times 5 is 140. What is our label? This is actual area, so this would be feet squared. Area is feet squared. So the area would equal 140 feet squared. There's our answer. Makes sense, right? You could also use a proportion to solve this, okay? And you could proportion out and find out what the length of the width and the length are in the actual room, and then multiply those two numbers together. That would also give you 140 feet squared. Either way, you get the right answer. Okay. Flip her over to the back. All right. The two easiest problems, I think, because this is just what we were doing right a couple weeks ago or last week. Okay. So we're solving for the variable. Okay. First step, rewrite it. Don't tamper with the evidence. Negative 3p plus 4 equals negative 17. In order to isolate the p, I need to solve by undoing. To undo the 4, I will subtract 4 from both sides. Negative 3p gets brought down, equals negative 17 minus 4. Negative 17 minus 4. Negative 21. You can do that without a calculator. Since I have the calculator sitting right here, so it makes it a little easier. Okay, negative 3p is multiplication. We need to do the opposite. Now, do we divide by 3? Not quite. I've seen a couple kids do this. We don't divide by 3 because then we'll end up with negative p. We don't want negative p. We just want regular p. Okay? So negative 3 should be divided by negative 3. That would equal 1, which will give us our p. Okay? So if we divide by negative 3 on this side we better divide by negative 3. Those cancel. P equals negative 21 divided by negative 3 equals regular positive 7. There's our answer. Now, this one over here, B. Negative 5p is greater than or equal to 40. Okay? Step 1, rewrite it. Step 2, draw our line down it. Okay, negative 5 and p are being multiplied together. We need to do the opposite, which is divide. Once again, since there's a negative sign attached to that 5, we need to divide by negative 5. If we divide by negative 5 on this side, we need to divide by negative 5 on that side. End up with p. All right, now here's a little trick, and I'm not sure everyone fully understood this. When you're solving one of these and you have a greater than or greater than and equal to or less than and equal to, basically any inequality sign, and you divide by a negative number, you must take this sign and flip it. So it was greater than or equal to, now it's less than or equal to 40 divided by negative 5. 40 divided by negative 5 equals negative 8. So P is less than or equal to negative 8. There's a little trick there. Okay. The next two questions are probability. Okay. We may not have touched on probability yet this year, but doesn't mean we can't solve these. What is the probability of tossing two fair coins and having both land heads up. So I got a couple dimes here, okay? Dime and another dime, okay? I'm going to toss both of those in the air, okay? First, I'm going to toss one of the dimes. I have a 1 out of 2 chances. There's 2 sides. It could land on either side. And I have 1 shot at getting a heads, okay? So my probability of this coin when I flip it landing on heads is 1 over 2, okay? Now I have that. I hit heads, okay? Good. Now I have my second coin. Ta-da. Okay, once again, I have 2 possible outcomes, a heads or a tails, okay? I have 1 shot out of those 2 of hitting a heads, okay? Also a 1/2, okay? When you're determining probability, you want to multiply those 2 together. 1 times 1 equals 1. 2 times 2 equals 4. The probability of flipping these 2 coins and having both land heads up is a 1 out of 4 chance. Both land heads up. Not too bad at all. Number 7. What is the probability of rolling a prime number on a fair number cube and flipping a tail on a fair coin? Well, if we think of a number cube, we're thinking of a dice, okay? And there's numbers 1, number 2, number 3, number 4, number 5, and number 6 on that die, okay? We need to know what are the prime numbers. Prime numbers are numbers where only 1 and itself can be divided in. So our prime numbers are 1, 2, 3, 5. Those are our prime numbers. The only numbers divisible by 1 are 1 and itself, I think. Now I'm getting this vague recollection that 1 is not a prime number. Do you guys think I'm right? I'm going to pause the video and I'm going to go look that up. My question now, I'm thinking I did this question wrong. Is the number 1 a prime number? Not sure. Hold on. I'm going to pause it and I'll be back with you guys in 1 second. By the miracle of technology, I'm back already. That was actually 10 minutes. And I went down and spoke to my favorite math teacher. We'll let you guess who that is. And they informed me number 1 is not a prime number. Okay? Number 1 is not a prime number, so I was incorrect in giving you that information. So the only prime numbers on a dice are 2, 3, and 5. Okay? 2 is divisible by 1 and itself, 2. 3 is divisible by 1 and itself, 3. And 5 is divisible only by 1 and itself. Okay? So 2, 3, and 5. So I have on a number cube, okay, on a number cube, okay, I have 6 possible numbers that I could roll, and 3 of them are prime. So I have a 3 out of 6 chance of rolling a prime number, okay, and multiply, that means. In this instance, and usually means adding, but this means multiplying in this case. Okay. The second thing we're going to do is flipping a coin. Bring my coin back. I have a chance of hitting a tails 1 every 2 times, so 1 over 2. I'm going to multiply those 2 fractions together. I get 3 over 12, or if I want to reduce, 1 out of 4. My probability of rolling a prime number on a fair number cube and flipping a tail on a fair coin, 1/4 chance. There you go. Thanks for bearing with me. All right, let's look at number 8 here. Number 8 says subtract 2x minus 3 from keyword, from 5x minus 1. If I'm subtracting something from something else, my bigger number goes on top. What I'm subtracting from goes on top. So 5x minus 1 should go on top. We're going to line this right up, and we're going to subtract, line this up, 2x minus 3. So we lined our x's up, lined our numbers up. Okay, I saw a lot of people that were just saying, well, this one's first, so I subtract 2x minus 3 goes on top, 5x minus 1 goes below. Pay attention to that keyword from. Okay, so from this, I'm subtracting this. Okay, so I take -1 minus -3. -1 minus -3 gives me +2. 5 minus 2, 5x minus 2x, gives me 3x. So my answer is 3x plus 2. Number 9, Raleigh pays 70% of the original price of a sweatshirt. Look at that word, of. It is bolded. Probably important.
Caitlin Dowd, please come to the office. Caitlin Dowd.
So it says Raleigh pays 70% of the original price. Okay, so it's not that he's getting 70% off. He's paying 70% of it. Okay, if the sweatshirt's original price is $50, what is the sale price? There's a really easy way to do this, and I'm not sure if every math teacher would love me doing it this way, but when I'm in a store, this is what I do. Okay, I take my original price, okay, $50, and I'm going to multiply it by 70%. But I can't multiply by a percent. I need to convert that to a decimal. You guys need to be quick at converting percentage to a decimal. 70% is 0.7. Okay? 2 places. Move the decimal 2 places. It starts here, goes here, here is 2 places. The decimal goes here, 0.7. So I'm multiplying $50 times 0.7. 7 times 0 is 0. 7 times 5 is 35. I have 1 decimal place right there, so I know I have money, so there's my other 0 there. How much is the sale price? How much is Raleigh paid for, how much does he have to pay for the sweatshirt? $35. He pays $35. If that word was the word off, he wouldn't pay $35. He would get $35 off, and we would have to take our $50 and subtract 35 and get 15. So if that word says off, the answer is 15. If it says of, it's 35. That one letter, that F, tells us what we need to do. Okay? It makes all the difference in the world, and you need to read closely. Okay? And number 10, which is the better deal? A 20-ounce bottle of water for $1.49 or a 16-ounce bottle of water for $1.29. Okay? We need to do unit rate like we did at the beginning of the year. Let's practice it. Okay? So for this one, we're going to take our $1.49, divide it by 20 ounces, and we'll find out what's the price per ounce for that. 1.49. Divide that by 20, gives us 0.0745. Okay? And we'll leave it as is for now because we'll have to see what we're comparing to, but eventually we could round to 2 places. That's how many places money is. Okay, so the second one we need to do the same thing. Take our price, $1.29, divide that by our ounces, 16. Grab the calculator, 129 divided by 16. That is 0.080625. Okay, so now we look at those two. 7 cents is cheaper than 8 cents. So therefore, the better deal is the 20 ounce. Exclamation point, because we are done. That was review number 10.